6.1 Rational functions and multiplying and dividing rational expressions. So if you did not review factoring and are not fully comfortable with factoring, pause this video and get comfortable with it. We need to make sure you're comfortable with factoring before we talk of anything to do with chapter 6.1 and on. So a rational expression can be written in the form where p and q are both polynomials and q cannot be 0. So these are rational expressions. That means we have letters on top of letters, fractions. That's just all that means. So let's find the domain of a rational expression. To find the domain, you set the denominator, which is the bottom, equal to 0 and solve. We set the bottom equal to 0 because the bottom cannot be 0. That's undefined. So we need to know what makes the bottom work or not work. So no matter what, we just set the bottom equal to 0. So bottom equal to 0. So can't be equal to 0. Because that's what it can't be. Let's put that in there. So let's put can't equal to 0. So that doesn't make any sense. 3, 0, that's not true, okay? Since that's an untrue statement, the domain is all real numbers. So x such that x is any real number. Or you can say negative infinity to positive infinity. So that's our domain. Alright, next we go on to 5x squared minus 3 over x minus 1. So we just take the denominator and set it cannot equal 0 and solve. So we add 1 over. And when we do, we say x cannot be 1. Because if we plug it back in, that's 0, right? So that doesn't work. So our domain is x such that x cannot be 1. Or if you want to be interval notation, if you have been studying it already, is negative infinity 1, union 1 to infinity. Alright, we have 7x minus 2 over x squared minus 2x minus 15. Doesn't matter what it looks like. If it's a fraction, set the bottom equal to 0. So we have x squared minus 2x minus 15 cannot equal 0. We're going to factor because this is a trinomial. So we factor into x minus 5. X plus 3 cannot equal to 0. You need to know how to factor. We set each of these equal to 0, so we have x minus 5 cannot equal 0. X plus 3 cannot equal 0. We're going to solve for x, so add 5. And when we do, we have x cannot equal to 5. Do the same thing to the right side. We subtract 3 to both sides. So we say x cannot equal negative 3. So there's two ways to write it. We could say x such that x cannot equal negative 3, comma, or and, you can write and, x cannot equal 5. Or in interval notation, this would be negative infinity, negative 3, union, negative 3 to 5, union, 5 to infinity. Whenever you have a fraction, just bottom cannot equal 0. That's how you set it up, and you'll find your domain every time. Alright, simplifying rational expressions. So to simplify a rational expression, it means to write it in its lowest terms or simplest form. You completely factor the numerator and the denominator of the rational expression, divide out factors common to the numerator and denominator. Warning though, only common factors can be eliminated from the numerator and denominator. Make sure any expression you eliminate is a factor. So a factor is separated by plus or minus. So that means this is a factor, that's a factor. Each of those are factors. And the same thing here. You can only cancel out inside whole parentheses. So you can't do this, do not do this. You cannot do that. Why? Because this is x minus 3, this is x plus 2. They're different. Here at the end, you see how it's x plus 4, x plus 4? Those are identical factors, so we can cancel them out. Alright, in order to simplify, we need to factor top and bottom. So let's factor the top and bottom. We can factor the top into x minus 4, x plus 4, x minus 1. And we can factor the bottom into x minus 5 and x plus 4. Let's see if we have any common parentheses. We do. X plus 4, x plus 4. Those are identical. What we have left over is x minus 1 and x minus 5. Those are not same parentheses. So that's our final answer. Alright, moving on. We have 7 minus y over y minus 7. That's the same, but different, right? You're like, that's the same thing, but they're just switched. That always equals negative 1. But let me show you why it equals negative 1. So we like to see the variable first. So negative y plus 7 over y minus 7. We're not really big fans of having that negative, so I'm going to divide it out. So I'm just going to take it out. I'm going to put it on the outside, meaning I switch the signs. So negative y becomes positive 7 becomes negative 7 over y minus 7. So you see how now we have parentheses, so factors that are the same, we cancel them out, and we're just left with negative. If we're just left with negative, we're actually left with negative 1. But if it looks like this, they're like identical, they're just flipped on top or bottom, just one of them is flipped from each other, it's always negative 1. Alrighty. This is factoring cubes. So if you need help factoring cubes, pause this video, look on the factoring review sheet. Also, you can just go to Google or YouTube and factor cubes. It'll teach you. So to factor cubes, I will kind of review it a little bit. So I'm going to take the top one out. We have x cubed plus 8. So I'm going to actually review this with you. The formula is a plus b times a squared minus ab plus b squared. So a is the cube root of x cubed, which is x, and b is the cube root of 8, which is 2. So we're just going to plug them in. We'll have x plus 2 times x squared minus x times 2 plus 2 squared. We're going to simplify. We have x plus 2 over x squared minus 2x plus 4. So that's what the top equals. The top is x plus 2 over x squared minus, times x squared minus 2x plus 4. And on the bottom, we cannot factor that, so we just do x plus 2. Let's cancel out like terms. Those cancel. So what we're left with, our final answer, is x squared minus 2x plus 4. Alright, let's factor the top. So the top, they only have 2 in common, so we have to take the greatest common factor out. So when we do, we're left with y squared plus 1. And now we factor the bottom. So I'll actually take that bottom out. I'll take it out. We have y cubed minus 5y squared plus y minus 5. We're going to factor by grouping here. So what I'm going to do is I'm going to group these together and that together. Why? Because they both have y squared in common. They both have a bunch of y's in common. So that's what we're going to take out. We're going to take out the y squared. So we have y squared, and when we take it out, we're left with y minus 5 plus y minus 5. There's always a 1. There is always a 1 right there. There's always a 1. So when we factor by grouping, we'll have y squared plus 1. And then we have y minus 5. Remember, because we don't write them twice, we just write them once. Y minus 5. I'm trying to write them. And our next factor is y minus 5. Remember the doubles, we don't write twice. So I'm going to put that on the bottom. The bottom factors out to y squared plus 1 over y minus 5. Let's cancel out identical factors. So what we're left with is 2 over y minus 5. Alright, multiplying, dividing. Dividing, that's the one where we do the keep, change, flip. If you don't know about that little phrase, I'll teach it to you when we start dividing. So when we divide and multiply fractions, we still want to factor everything out. That's like the first thing you want to do when we're talking about polynomials, factor. So m minus 2 squared, that's the same thing as m minus n and m minus n. I know I said that weird. It's m minus n squared, my bad. On the bottom, we can't factor that, so that's m plus n times, I can't do anything onto the m, so m over, I can factor here, we can take an m out, so we're left with m minus n. When we have fractions, we cancel diagonal and up and down, never side to side. Diagonal, up and down. So up and down, we have m's. Diagonal, we have m minus n. So what we're left with is m minus n over m plus n. Now that we're dividing, we keep, change, flip. So I'll tell you what that means. We keep the first one identical, we change the sign to multiplication, and we flip the second one. Now we factor and do all of what we're supposed to do. So on top, we can separate this into x plus 3, x plus 3. 5 I can't do anything with. 25 is just 25. And on the bottom, I can factor 5 out. So we'll have x plus 3. Alright, now let's simplify top and bottom. So here we have a top and bottom that matches. 25 divided by 5 is 5. Diagonally, we can cancel out x plus 3, x plus 3. You might see it. You might see it. It's okay if you don't. I'm going to point it out here. We still have 5 left and another 5. So we can cancel those because they are diagonal. What we have left over, literally the only thing we have left over is x plus 3. Alright, we're dividing again, so we just keep, change, flip. We keep the first one. So we keep the first one, we change division to multiplication, and we flip the second one. Now we factor everything. So I'm going to bring all of this out. Alright, our first one, we have 18y squared plus 9y minus 2. We can simplify this. We can simplify by factoring. So when we factor, we have 6y minus 1 and 3y plus 2. We keep factoring. I'm going to factor the bottom now. So we have 24y squared minus 10y plus 1. Let's factor that. We can factor that into 6y minus 1 and 4y plus 1. Excuse me, minus 1. I wrote that down backwards. Nope, we're good. My bad. Don't pay attention. Okay. Now we factor the right side. So we can factor 8y squared plus 18y minus 5. We can factor that down into 4y minus 1 and 2y plus 5. Last but not least, we factor the bottom, so 3y squared plus 17y plus 10. And when we factor this, it factors into 3y plus 2 and y plus 5. So now that we factored it, let's go ahead and put them where they're supposed to go. So on the top, we simplified that to 6y minus 1 and 3y plus 2. On the bottom of that, we simplified that to 6y minus 1, 4y minus 1. And that's times, so I'm trying to get full screen again. That's times 4y minus 1 and 2y plus 5. And that's over 3y plus 2, y plus 5. Alright, let's top and bottom cancel. So top and bottom, we can cancel out 6y minus 1, 6y minus 1. And top and bottom, let's see, can we cancel anything more out? Nope, not top and bottom. So let's talk about diagonal. So diagonal, we have 3y plus 2, 3y plus 2. And then we also have 4y minus 1, 4y minus 1. So all we are left with is 2y plus 5 over y plus 5. Alright, here we have a bunch of stuff going on. So we have multiplication and division now. We treat it very similar. So we're just going to flip this side right there. So we do nothing with the first term. We have x minus 25, x plus 5 squared, times 3x plus 5, 4x. We change the sign and we flip the second one. So all we do is just change the division to multiplication and flip whatever comes after the division. All right, now that we change flip, let's factor. So we can factor the top into x plus 5, x minus 5, that's a difference of squares. And on the bottom, that's x plus 5, x plus 5. 3x plus 5, can't do anything there. 4x, that's just 4 times x, can't do anything there. And then x is just x. And on the bottom, we can factor that into x minus 5, sorry, and x plus 2. Alright, we can cancel diagonal. So literally any diagonal and up and down. So up and down first. We do x plus 5, x plus 5. That's it for our diagonal. Okay, now for up and down. Let's do diagonal now. So we'd have x minus 5, x minus 5. And then we also have x. There's no plus or minus in between there, so we can cancel out those x's. So let's write what we have left over. That's a 15. That's a 15. That's okay. We're just going to write what we have left over. That's 15. My bad. I'm going to write what we have left over. On here we have nothing, so we have a 1 over x plus 5. And that's times 3x plus 15 over 4. And that's times nothing over x plus 2. Remember, nothing is 1. We can keep factoring. My bad. It happens. So we have 1 over x plus 5 times 3 times x plus 5 over 4 times 1 over x plus 2. We can cancel out the x plus 5s here. So all that we're left with is 3 over 4 times 1 over x plus 2. Multiply straight across. So we have 3 over 4 times x plus 2. Never multiply the bottoms. We keep it factored. Keep that bottom factored. For the ICL production company, the rational function describes the company's cost per disk of pressing X compact disks. Find the cost per disk for pressing. This is going to be given. This is given to you. Well, you're always going to be given something to plug it in. So this is what we're given. We have C of X equals 2.6X plus 10,000 over X. So it told us that X, that's compact discs. So this stands for X, 1000 stands for X. We're going to plug them in. So let's plug them in. We have cost equals 2.6 times X, which is 100, plus 10,000 over 100. We're going to simplify. So 2.6 times 100 is 260, plus 10,000 over 100. Combine like terms on top, so we get 10,260 over 100, and that is 102.6. So it cost $102.60 to produce 100 compact discs. Now let's figure out how much it costs to do 1,000 compact discs. So we have cost equals 2.6 times 1,000 plus 10,000 over X, which is 1,000. So 2.6 times 1,000 is 2,600 plus 10,000 over 1,000. Combine like terms on top, so 12,600 over 1,000, and we get, so why does it cost more to make less? Because the more you make, the more money you get, and the less you're spending over time. It's like shopping at Sam's Club and buying stuff in bulk. It costs more up front, but at the end, you are saving so much money.